Today we're going to go over dividing polynomials using long division. So this can be helpful when we're trying to factor. If our factoring strategies don't work, we can always try using division to divide something out. And this is a lot of strategies that we're going to collect over the next few days. Now let's remind ourselves of how we did long division like back in elementary school when we were first learning how to divide. Let's say that I wanted to do something like 4 divided into 277. Okay, well, what did we do first? We said, okay, how many times does 4 go into 2? It doesn't. So we move on. How many times does 4 go into 27? Well, 4 times 6 is 24, so 6 is what we would choose. And then what's the next step? 6 times 4 is 24, and then we subtract, so we get 3. Next step, bring down the 7. And now we look at it again. How many times does 4 go into 37? Well, 4 times 9 is 36. And when we subtract, we get 1. 1 is the remainder, so we get 69 1/4 when we work that out. Okay, that strategy is exactly the same strategy when we are dividing polynomials. So the first step is to do a little bit of organizing. The first thing we need to do is arrange our polynomial in standard form, and if any powers are missing, we need to insert zeros. And I'll show you what I mean there in a minute. We're going to divide the first term by the first term of the divisor. The divisor is what's under that division bar. And then we multiply, subtract, bring down. And you keep doing that until you run out of terms. So we're going to practice this. All this written out in words makes a lot more sense after we have done a couple of these ourselves. So let's start with number 1. First thing we need to do is make sure that we are in standard form. So here's our first polynomial that is in standard form, and we are dividing by x plus 3, which is also in standard form. So let's set up our division problem. We want x plus 3 into x squared plus 10x plus 21. All right. Now, we always compare the first term and the first term. We don't care about the rest. It's all going to work itself out along the way. Those are the only two that we ever look at. So x squared divided by x, or you can think of it x times what makes x squared. X squared divided by x is x. Now you want to line it up above its like term. So I'm going to put x right here. Now what we're going to do is we need to multiply. We need to multiply by the whole thing. So that means essentially you need to distribute it. Again, line up your like terms. So x times x is x squared, and x times 3 is positive 3x. Okay, let's get rid of that extra stuff on here now. Now we are ready to subtract. Now remember, when you subtract, we have to subtract the entire polynomial, which means we're going to change all of the signs. Now here's a strategy that I learned a few years ago that I think is very helpful when you're taking notes. Because what we like to do a lot of the time is just come through and say switch, switch. Now, when you look at your notes a week from now, you're not going to remember whether that negative was already there or whether you put it there. So anytime I switch the sign, I like to circle it. That way, when I come back and look at this later, I can see, oh, that was something I did. That wasn't something that was already there. Once we switch all the signs, that's the subtracting piece. Now we just combine like terms. So x squared and negative x squared is going to make 0. 10x and negative 3x is going to make 7. And then we bring down the plus 21. And now the process starts again. This time I compare the first term x with this first term 7x. So 7x divided by 7 is positive 7. Distribute that 7, so we get 7x plus 21. Switch your signs, so this becomes negative and this becomes negative, and we end up with 0. So in this case, our remainder is 0. Now, all of this work we just did is our division algorithm, but it doesn't tell me that you know the answer. So be sure that you state your answer is x plus 7. That's what we get when we divide that out. Okay? Let's look at another one. Number 2. First thing we need to do, again, is make sure that everything is in standard form. This one is not, so let's rewrite it. This is what we get when we put that first polynomial in standard form, and we are dividing by 3x minus 2. Okay, so let's go ahead and set up our division algorithm. Now I'm going to work through this one, but I would encourage you to put the video on pause and try this first on your own so you can see if you're getting the hang of it, and then come back in 3 seconds as I work through this and explain the steps. All right, first term with first term. 6 divided by 3 is 2, and x cubed divided by x is going to give us x squared. So 2x squared is what we want. 3x times 2x squared is 6x cubed. All right, and again, we're lining it up above the squared. Now distribute. 6x cubed minus 4x squared. Switch your signs. This one becomes negative. This one now becomes positive. And so when we combine like terms, we get 0x cubed and we get 5x squared. Whoops, folks, I've made a mistake, and I'll show you where it is. I miscopied, maybe you caught it. This, when I put this in standard form, I lost the sign of my x squared. That should be a negative x squared, which means we need a negative right here. So when we add, instead, we get 3x squared. Sorry about that. Go ahead and pause and make sure that you get that corrected before we move on. But that is correct. Now, we can bring down the negative 5x. And now we're going to compare first term and first term again. So 3x times x makes 3x squared, so we get just a positive x here. Distribute 3x squared minus 2x. Change our signs, negative, positive, and add straight down, so we get negative 3x. One more time, we need to bring down plus 4. Now here when we compare, we can see that we need a negative 1. Distribute your negative 1, so we get negative 3x plus 2. Switch the signs, this becomes positive, this becomes negative, and here we're left with 2. That's our remainder. Now remember, all that work was the algorithm. We haven't answered the question. The answer to the question is this, and this is how we write the remainder. We have 2x squared plus x minus 1 plus 2 over 3x minus 2. Okay? That's how you write your remainder. You always put it over whatever you were dividing by. Okay? This is just like in the first example we got, the remainder was 1, and we said it was 69 and 1/4 because 4 is what we were dividing by. So it's going to be that polynomial plus 2 over the thing we were dividing by, 3x minus 2. All right, I want to help you set up number 3, and then I'm going to let you try this one on your own. Number 3 is a little bit different because when we go to put this in standard form, we'll see that we are missing some powers. So if we look at the original 6x to the 4th plus 5x cubed plus 3x minus 5, that is in standard form, but you'll notice that there is no squared term. We have 0 x squareds. When we divide here, you'll notice also we are missing the constant term, so we will have 0. That's important. We need to fill both of those in before we work. So when we set up our division, we want to divide 3x squared minus 2x plus 0 into 6x to the fourth plus 5x cubed plus 0x squared plus 3x minus 5. Essentially, it's like place value. You have to put in a 0 for the place that isn't there. Like, I can't write 11 and tell you that that's 101. If I want it to say 101, I have to put a 0 in the tens place to show that that place value is there. It's very similar. Okay, now that we've got this, go ahead and put this on pause and try this one yourself. The number of terms doesn't make any difference because we're just looking at the first term and the first term. You're only comparing here and here. I'll come back in 3 seconds with the answer. This is what you should get once you've run your algorithm. And so now the way that we would write the answer is going to be 2x squared plus 3x plus 2 plus 7x minus 5 over 3x squared minus 2x. We don't need the extra zeros in there now because they're not really necessary when you're just writing it, but when we're dividing, they are. And so this is your answer. There is one more problem in the notes that you can go ahead and try yourself and use the PDF that's posted online to check your answer, but I will leave that for you to take a look at on your own, and I will see you next time.